students, to the part 2 of the fall semester review video series. Let's go ahead and get started with these problems on your semester exam. Problems like this could exist, and what we're doing here is we're reviewing inverse trig functions. Okay, we're reviewing inverse trig functions. Okay, and a way that we write inverse trig functions is by using arc cosine, arc cosine, arc sine, etc. And what that means is this. Let's go ahead and jump right into this problem right away, okay? Whenever you see an arc cosine of something, it just simply means this. In this case, we're using cosine. So you would write cosine of, and then you can use any variable you want for your angle. X, theta, y, ABC, whatever. I'm going to use x equals 1. So do you see how simple this is? Whenever you see arc something of a number, it just means find the angle, so that when you take the cosine of that angle, you get out this number here, in this case 1. So let me sum it up by saying this. Whenever you're given an arc cosine, this whole thing right here always equals a what? Don't miss this. This is really important. This is really, really important. Anytime you're given an arc something, the whole thing equals an angle. Please don't forget that, okay? Alright, moving on. So let's go ahead and solve this. Now remember how you were given special triangles? Well, if you'll think of your special triangles, none of your special triangles had cosine of an angle giving you 1. None of them. So what we're going to have to do is this. First of all, you have to remember whenever you're dealing with arc cosine, you're dealing with, do you remember? I hope that you do. We're dealing with quadrants 1 and 2. Okay? Whenever you're dealing with arc sine or arc tangent, you're dealing with quadrants 1 and 4. Please don't forget that. That's for arc, sine, and arc tangent. Okay? So, back to this problem over here. We're looking for the angle that gives us a positive 1. So it's got to range somewhere from here all the way to here. Okay? So, I'm going to try, since I have a 1 here, more than likely it's going to be one of my axis angles, or quadrant angles, they're called. And so I'm going to type in cosine of 0 and see what I get. Cosine of 0 is going to give me 1. So far so good. There's one answer. Now I'm going to try the cosine of 90. The cosine of 90 gives me 0. And then the cosine of 180, and that's going to give me negative 1. Okay? So, the only angle, there's more, listen to me students, there's more than one angle that works for this equation. Did you hear me? There's more than one angle. However, since your original problem was an arc problem, then we know that we're restricted to these two quadrants here. So your answer is 90. Okay? 90. Cosine of 90 equals 1. Let's move on to problem number 2. Now this one here on the test, I would not let you use a calculator on this one, okay? I would not let you, hold on a second students, I really didn't want to do that, sorry. I would not let you use a calculator on this problem right here, because this is one of our special angles that we should know. Okay, and I'll go over that in just a second for you. But first of all, let's remember this. Arc sine of this number means what? Sine of an angle equals negative square root of 2 over 2. Now, next, we're dealing with arc, so we're going to go to quadrant 1 and quadrant 2. Now, sine is positive in this quadrant, sine is negative in this quadrant, so we know we want to be in the fourth quadrant here. Okay, we know we want to be somewhere in the fourth quadrant, because I want to get out a negative square root of 2 over 2 when I take the sine of some angle. Okay, now we got to find this angle. Well, as soon as I think of square root of 2, I think of my 45, 45, 90 triangle. Remember, 1, 1, square root of 2. Okay, now more than likely, students, the way I got this was I rationalized my denominator. Okay, so more than likely, what I had at first was this. See if this makes sense. Please watch carefully. There we go. More than likely I had this, and I multiplied both sides by square root of 2 over square root of 2, and then I got this. Now if I'm really confusing you, then stop and think. Remember that table I gave you guys? Remember that table I gave you guys with sine, cosine, tangent, cosecant, secant, and cotangent. Then up here I had 30 degrees, 45 degrees, 60 degrees, so on and so forth. Use that if you want to, that's fine. Okay, I don't mind that. Either way you're going to see is 45 degrees. Watch, and I'll show you why. The sine of 45 degrees is opposite over hypotenuse, which is 1 over square root of 2. When you rationalize that, you get square root of 2 over 2. So the sine of 45 degrees is square root of 2 over 2, which is what I want. So I come over here and I put 45 degrees in my triangle. Now, please listen carefully. In the past, you guys have been so used to starting here and going like this and putting what for your answer. And that's awesome. That's fine. But you can't do that when you're dealing with a what problem? Arc. Because the arc has to stay between these two quadrants. In other words, your angle x has to be greater than or equal to negative 90 and less than or equal to 90. Because from here to here is 90 and from here to here is negative 90. Okay? So your x has to fall between those two numbers. So instead of doing going this way and saying positive 315, just go this way and say what? Negative 45 degrees. So there's your answer, negative 45 degrees. These can be difficult, so really, really, really study these and make sure you're ready for these on your final exam. Okay, now sometimes I'll let you just use a calculator, okay? No problem, here we go. Arc tangent of 2.34. We're going to rewrite that like this. Tangent of an angle equals 2.34. Now students, you should know what to do. Okay? Remember, with your calculator, anytime you're looking for an angle, you hit second and then whatever your trig function is. So with my calculator, I'm going to make sure first of all I'm in degrees, and I am. Second of all, I'm going to hit second tangent, and when I do, this pops up on my screen. Then I'm going to type in 2.34 and close the parentheses and hit enter. And I'm getting 66.86 degrees. Now, if you wanted your answer to be in degrees, no problem. Go back to your mode. Highlight radians, hit enter, come out of that screen, and now type it again. Second tangent of 2.34, enter. And you will get 1.166. So I'm going to put 1.17. Well, Mr. Earhart, could we not just take our degrees here and convert that over to radians? Yes, you could have. I don't mind that. I think it's a little faster to just quickly go to your radians mode and then type the problem in again. But whatever works for you is fine. Okay? Alright, moving on. Okay, these here. Alright, now, remember guys, we're always going to start working inside the parentheses first. So we're going to take this problem here first. Cosine. Now inside the parentheses here, please don't forget you're looking for an angle. Please don't forget that. Let me say that again. Anytime you're given an arc, cosine, this whole thing right here is always going to come out being a what? An angle. Please, please don't forget that, okay? So, moving on. Inside here I'm going to put cosine of angle x equals what? 0.25. I'm going to go ahead and put 1/4. Now students, I didn't say this earlier and I should have, so please make note of this in your notes. I apologize. On these problems here, I want you to have exact numbers for your answers. Exact numbers. So what that means is you just can't take your calculator right now and hit cosine, inverse cosine equals 1/4 and get out an angle. Okay? It's going to be a really long decimal. You can't do that. Now, so having said that, here's what we're going to have to do. We're going to have to find this angle using trigonometry and triangle cosine deals with quadrant 1 and quadrant 2. This is a positive 1/4, so I know I'm in quadrant 1. So I'm going to draw my triangle like this. Here's my angle x. X, got it? Okay. Opposite over, or excuse me, cosine is adjacent over hypotenuse. And so this would be square root of 15 right here, using Pythagorean's theorem. Now, this is your angle. Do you see it? This is your angle, guys. Got it? This is your angle, okay? Remember, this whole thing here simplifies down to an angle. So I did all of this here to get out my angle. What is my angle? X. Well, Mr. Earhart, that's dumb. You just called it X. Yes, I did call it X, but look how I set it up down here. I've got it set up perfectly. I mean, it's perfect. So I can put cosine of, and this whole thing here became angle x. And now I can find the cosine of x by using this triangle here. And the cosine of x is 1/4 adjacent over hypotenuse. Mr. Earhart, you went in a big circle. I did, but I had to. Because if you're thinking that every time you have cosine, then arc cosine, or sine, and then arc sine, if you're thinking every time you have that whatever number you have here will always be your answer, that is not always the case. Not always. There are exceptions to that. So the safest thing to do is to work it out and make sure you have the right answer. It really, really is. Okay? Alright. If you need to back that up and watch it again, feel free to do that, alright? Okay, let's go ahead and take a look at this one here. Now here we're going to start on the inside and find the cosine of negative 5 pi. Okay, the cosine of negative 5 pi. Now, negative 5 pi would be this, students. We're going to rotate around once, that's 2 pi, 4 pi, and then here's 5 pi. So really we're looking at the cosine of 180 degrees. Okay, now students, we can quickly find that, and you can use a calculator because you're going to get out a whole number. The cosine of 180 is going to be negative 1, I believe. Yes, negative 1. So the cosine of 5 pi is negative 1. So now I have arc cosine of negative 1. Okay? Now, let's go ahead and rewrite that quickly. So now I have cosine of an angle equals negative 1. Now I'm dealing with arc cosine, so I know I'm going to be in quadrant 1 or 2. Okay? Well, negative 1, the only angle that's going to give me negative 1 from here to here is going to be one of my quadrant angles. So it's either going to be 0, 90, or 180. Well, it's going to be 180. The cosine of 180 is negative 1. So the answer is 180. Now, do you see what happened here? You got an arc cosine and a cosine. So some students think the answer right off the bat would be negative 5 pi. And that's not true. Your answer ended up being pi or 180. Okay? Either one of those two answers would be acceptable, depending whether you wanted degrees or radians. So just always work it out, guys. That's the safest way to do this, okay? Alright, moving on to this number over here. Okay, here we go. Now, we're going to start off with arc cosine in the parentheses. So I'm going to write cosine of angle x equals 3/5. Okay, fair enough. Now, I'm going to draw my triangle here. Arc cosine, so I'm in quadrant 1 or quadrant 2. This is a positive 3/5, so I know I'm in quadrant 1. But angle x here, adjacent over hypotenuse, using Pythagorean's theorem, this would be a 4. So, look what I did. Remember, guys, anytime you're given an arc problem, the whole thing always equals a what? An angle. Please don't forget that, okay? So, this whole thing here equals an angle, and I have my angle, tangent of angle what? X. Now, I could have called this angle theta, y, a, b, c, d, e, f, it doesn't matter. I chose x. But now that I have my triangle all drawn here, I can take the tangent of x, and that would be opposite over adjacent, so the answer would be 4/3. Okay, alright, moving on. Find the other 4 trig values by using trig identities only. All work must be shown. Okay, no problem. We're looking for sine, cosine. We already have tangent. And we're looking for cosecant. Secant we already have. And then cotangent. Well, let's do what I kind of call the duh stuff first. I mean, obviously, well, first of all, let's find out what quad we're in really quick. It's very important. Secant is the reciprocal of cosine. So we're looking for a quadrant where tangent gives you out a positive number and cosine gives you out a positive number. Always establish your quadrant first, guys. That would be quadrant 1. Quadrant 1 is the only quadrant in which tangent is positive and cosine is also positive. So I know I'm in quadrant 1, okay? So please don't forget that. It's very important that we know that. Okay, now, because that influences all of the different signs, positive and negative, of our functions here. So I know everything's going to be positive because in quadrant 1, everything's positive. So that's a pretty big help. Now, real quick, if tangent is 2/3, then cotangent is 3/2. Piece of cake. Now, if secant square root of 13/3, then cosine would be 3 over square root of 13. We got to rationalize that. So we would get 3 square root of 13 over 13. Okay, so there we go. Not too bad, moving right along. Now, what trig functions can I use to find sine and cosecant? Well, for me, guys, I'm thinking, look, I can find sine pretty quickly. Then whatever I get, I'll flip it and put it over here for cosecant. So I'm going to look for sine. Right away, I'm thinking of this one. I don't know why. I just think of tangent x equals sine over cosine. Okay? Well, I know what tangent x is. It's 2/3. And I know what cosine x is. It's 3 square root of 13 over 13. Alright, let's get a new page up here so we have some room to work. Now, guys, this is my opinion. I'm going to cross multiply, okay, and try to get rid of these fractions a little bit. So if I cross multiply, 3 times sine is 3 sine x equals, and if I take 2 times this, I'm going to get 6 square root of 13 over 13. Okay? Now, let me show you how I did that real quick in case you're confused. 2 times this fraction here would be 2 over 1 times 3 square root of 13 over 13. And you take outside number times outside number. 6 square root of 13. 1 times 13 is 13. Now moving on. Divide both sides by 3. And I have my sine x number. So sine x equals this divided by what, guys? Watch. Divided by 3. Those cancel. Divided by what? 3. Well, you know what to do. You flip it and multiply. So it looks like I'm going to get 6 square root of 13 over 39. That looks like a really good answer. But guys, students, this number's an outside number. This number's an outside number. 3 goes into both of those numbers. So you must reduce 2 square root of 13 over 13. So there we go. We got our sine answer. Alright, let's take this and go back over here if at all possible. See if we can squeeze that in right there. Alright, so there's my answer. Now if we flip that, okay, we're going to get our cosecant answer. So students, to give me a little bit of room, I'm going to do some erasing here, okay? So if you haven't written this down, go ahead and write all this down. I now want to find the cosecant, so I'm going to take this and flip it. So, flip it. So it would be 13 over 2 square root of 13. Now we're going to rationalize. We're going to multiply the top and the bottom by the square root of 13, and we will get 13 square root of 13. Now be careful here. There's a 1 right is 13 square root of 13 over 26. And obviously your outside numbers can be reduced. 13 goes into both of those numbers. So there we have our final answer. Finally, we have square root of 13 over 2. Okay? So there we go. Not too bad. So we used all trig identities. And by the way, if you're confused on this 2 times 13, I'll just say this to you really quickly. 2 times 1 is 2. And square root of 13 times square root of 13 is square root of 169. And then take the square root of 169 and you get 13. So 2 times 13, which then gives you 26. Okay? I hope this has been a help to you. Let's go ahead and move on. Let's see. We're going to find cotangent x by using trig identities only. Well, guys, come on. They gave us what? They gave us what? Those two. And we got to find cotangent. Think of a trig identity that has cotangent, sine, and cosine. I know one. And by the way, for your exam, of course, you know you are allowed to have your trig identity cheat sheet. Okay? Cotangent of x equals cosine over sine. That's a trig identity that we've learned. Okay? So, for cosine right here, I'm going to put negative square root of 33 over 7. And for sine, I'm going to put 4 over 7. So we take our top fraction here, negative square root of 33 over 7, divided by this, divided by 4 sevens. And of course, if it's divided by 4 sevens, I'm going to flip the fraction and multiply. So times 7 fourths. This becomes really easy. These cancel. So your answer is going to be a negative fraction times a positive fraction is negative. Square root of 33 times 1 is square root of 33. 1 times 4 is 4. There's your answer. Okay? Cotangent of x equals this. Pretty simple, guys, really, okay? Alright, moving on. We're going to graph this. Now, these are really simple to do if you'll just remember the different things you've learned about arc trig functions or inverse trig functions. First of all, let's go ahead and rewrite this. Notice. Now, please listen carefully. Notice we're saying this entire thing equals what? Y. And I've also taught you this entire thing equals a what always? An angle. So in this problem here, your angle has to be what variable? Y. It has to be, because they're telling you, look guys, they're telling you this arc cosine equals Y. So they're giving the variable to you. In the past, you could use whatever variable you wanted to use. Not in this problem, okay? They're telling you arc cosine equals Y. So that's going to be your angle, okay? So with that in mind, here we go. I'm going to rewrite it like this. Cosine of what? My angle's Y equals what? X over 4. Okay? Now, usually students, in all of your graphing, you're used to putting numbers in for X and getting out Y values. Not when it comes to arc or inverse trig graphing, okay? We're going to put numbers in for Y. Now, I think it'd be a lot easier personally, guys, if we got X by itself. So I'm going to go ahead and multiply both sides by 4. And there we go. Now I'm going to put values in for Y, okay? Table of values. But remember something, students. Y, the angle Y, has boundaries. It does? Yeah. Arc cosine. Arc cosine tells you that the cosine angle is restricted to quadrants 1 and 2. That means whatever you put in for Y has to go from 0 to what? 180. So I'm going to use 0. I don't know, I guess I'd go to 45 next. And then 90. I'm just adding 45. I'm just trying to get just a little sketch of the graph. And 180. Okay, so with my calculator really quick here, I'm going to take the cosine of Y. The cosine of 0 times 4. Okay, make sure you're in degrees. The cosine of 0 is 1, and 1 times 4 is 4. Now take the cosine of 45. it's totally okay to have a decimal. That's fine because we're graphing it. So I really want decimal numbers or whole numbers. Now put 90 in for y. So cosine of 90 equals times 4 would give you 0. Cosine of 90 is 0 times 4 is 0. Now the cosine of 135 is going to be negative 0.707 times 4 gives you negative 2.83. And then we'll put 180 in for cosine. Cosine of 180 is negative 1. Negative 1 times 4 is negative 4. So hopefully we got a pretty good view of this graph, okay? Let's come over here and draw our coordinate plane. Now let's be wise with our tick marks, okay? First of all, the x-axis goes from 4 to negative 4, so I'm going to put it 5. Give me a little more space that way. Now my y values go from 0 all the way to 180. In fact, there's no negative y at all, so I really made a mistake here, in my opinion. I probably should have just done this, if at all possible. I really don't need any negative y-axis. So there we go. All I need is positive. So I'm going to go ahead and put, let's see, I'll put mine in, these are in increments of 1, 2, negative 1, negative 2. These will be in increments of 45. So 45, I might jack this up a little higher here. So 45, 0. 45, 90, 135, and then 180 right here. And I'm not sure what this is here. We'll call it, it's a blob, okay? Alright, now let's go ahead and sketch the graph here. So we're at 4, 0. So 4, 0. Then we're at 2.83, 45. So about right here. Then we're at 0, 90. Then we're at negative 2.83, 135, so about right here. And then we're at negative 4, 180. Now I know it's looking like a straight line, but please guys remember, it's not going to be a straight line, okay? It's going to be a curve, alright? And let me show you why. Mr. Error, how do we know that? You expect us to know that? Yeah, I do, because when you used to graph these right here, remember what they looked like? You should. They looked like this. Well, if you pick this thing up right here, and you flip it, you're not getting a straight line from here to here. It has a little bit of a curve to it. Okay, it's going to mainly curve here at the beginning, and then straighten out, and then curve at the end, okay? So, we're going to have a curve at the beginning, like this, a little bit of a curve here. Then it's going to straighten out. And then a little bit of curve here at the, end here, okay? Again, you guys know that, Mr. Lemon's job is not threatened by my artistic skills, okay? In fact, I just messed up pretty badly there on that one, so that's not even accurate. So probably, Mrs. Walker's job is not threatened either by my math skills. But come down, there should be a little bit of a curve. When you get about right here, there's a curve, okay? Like that, it curves down right there. And that's really what it looks like, okay? So please know that for your exam. There very well could be some of these on your test, okay? Alright, moving on. I am going to throw some good old-fashioned trigonometry word problems at you. You should recognize this from an old test. Two fire towers are 30 kilometers apart. A is due west of B. So here's B. Here's A, due west. Distance is 30. A fire is spotted due north of Tower B, so I better slide this down to give me some room here. A fire is spotted due north of Tower B. Remember, guys, when you're drawing your diagrams, that use just points and lines. Okay, points and lines. The bearing from A to the fire is north 45 east. Okay, so come on, guys, please know what that means. The bearing from A to the fire. I'm gonna put F for fire. Okay, so from here, from A to F, the bearing is this. Now, what's the? Come on, guys, you gotta know how to do this by now. What is the direction? North. So I draw a line going up north. And then I rotate what direction? East. Well, I don't rotate like this. That's going west. I rotate this way, going east, and I only do it 14 degrees. Okay, so I do it like this, and then draw the line. Now, I know that my drawing is not drawn to scale. It's not a big deal to me. Okay, so this angle here is 14 degrees. Okay, you gotta know how to do that. Okay, find the distance that tower A is from B. So this is my X right here. Students, this is basic trig, because you have a right triangle. So this is easy. If this, you know this, okay, you know this is a horizontal line. You know this is a vertical line. So you know this angle here is 90 degrees. So if that one angle there's 14, then this has to be 76. Okay? And this 30 right here really should be on the outside, so it's easier to see. There we go. So students, we're trying to find X. We have an angle, we have a side, and we have an unknown side. Based on this angle, this is my adjacent, this is my hypotenuse. So cosine deals with adjacent and hypotenuse. So cosine of 76 equals adjacent over hypotenuse. Multiply both sides by X to get rid of your fraction. And then to get X by itself, divide both sides by cosine of 76. So with your calculator, make sure make sure you're in degrees, okay, guys? But 30 divided by cosine of 76 gives you 124.006. So we're dealing with kilometers, so the distance is 126 kilometers. Okay, moving on. Alright, we're going to solve two equations so we don't get confused here. I'm going to grab this and drag it down here so that's all that you see. Okay, so we're going to start off with this one first. You've got to know how to solve trig equations on this test, students. Very important. So 3 tangent squared of 2x minus 1 equals 0. Now you're not taking the tangent of this whole thing because there's no parentheses around it. You're taking the tangent of 2x. So we're going to get tangent squared by itself. So we're going to bring the 1 over and make it positive. And then we're going to divide by 3. So you should end up with this right here. Tangent squared of 2x equals 1/3. Now, one of you emailed me about knowing when to put plus minus about a month ago, and I said to you, whenever you choose to put the square root in, if it's not there in the original problem, and you choose to put it in to solve, then that is when you have to put plus minus. Well, we're going to put a square root in because we have a tangent squared. So I'm going to take the square root of both sides. So I must put the plus minus, okay? So there we go. Now, let's simplify this right here. The square root of 1/3 is the same thing as the square root of 1 over the square root of 3. Okay? Well, the square root of 1 is 1, so 1 over square root of 3. Then if I rationalize that, square root of 3 over 3, I really have this. Tangent of 2x equals square root of 3 over 3. Okay? Now, so there I've taken all of this and simplified it down to this. So it's really not too bad. Let's get this out of the way and let's erase all of this work. So I took that whole original equation and I got it down to this. Now, let's go ahead and solve for this angle here, this x. The first thing we do here, students, is we realize, okay, I want an angle that gives me a positive square root of 3 over 3. I did not have an arctangent. Okay, that's just a good old trigonometry word problem. So I want to know which quadrants tangents. I'm not restricted to two quadrants. Okay, this is not an arctangent problem. So where's tangent positive? Here and here. So I'm going to draw my triangle here and my triangle here. Now, what angle? Well, if you'll look at your chart that I gave you, you'll see the tangent of 30. Okay, gives you this. So this whole entire angle here has to be 30. So I'm going to put a 30 here and a 30 here. So one answer could be 30, and the other answer would be 180 plus 30, 210. Here's the problem. Those are not my answers because I'm solving for x. So in other words, students, the entire angle here is 30. So 30 equals 2x. So really, my answer for x would be 15. We've done these before. They're really a pain in the neck. Now if you look here, your answer has to range between 0 and 2 pi. Now to be honest with you, I'm not setting a very good example right now because this is 2 pi. My answer is supposed to be in radians. So 15 degrees is your answer. If you quickly convert that over to radians, you're going to get pi over 12. And that really should be the answer you use. So are we still within our boundary here, the given interval? Yes, we are. So now, remember you always add 360 to your angle. So now we're at 390. Okay, so divide that by 2, and we're going to get 195 degrees. But that has to be in radians, of course. So we're going to convert that to radians, and we're going to get 13 pi over 12. Well, we're still within our boundary between 0 and 2 pi. Let's go ahead and go 390 plus 360. And we're going to get 750. So 2x now equals 750. Divide both sides by 2. And you'll get 375 degrees. But we want it in radians, okay? And I think that's going to go too far right there, to be honest with you. It should go too far yet. Well, if you convert that to radians, you're going to get something bigger than 2. Look what you're going to get. You're going to get 25 pi over 12. Now, Mr. Arrow, how do you know that's bigger? How do you know that's bigger than 2? Because 25 over 12 is 2 and 1, 12 pi. So it's bigger than 2 pi. So you do not accept this answer. So far I have 2 answers. 1, 2. Now, students, in about 3 seconds, I'm going to erase all this. So if you're not done, pause the video and copy this down. Okay, I'm going to erase it. 3, 2, 1. All right, here we go. Now let's take 210 degrees. And if you don't believe me, go ahead and do this. Go ahead and take the tangent of 210, and you will get the exact same decimal equivalency as square root of 3 over 3. So the whole angle is 210. So I'm going to take 2x and set it equal to 210. Okay, so 210 divided by 2 gives me 105 degrees. But I want my answer to be in radians, so I'm going to convert that over to radians, and I'm going to get 7 pi over 12. So far I'm between 0 and 2 pi. I'm good. Now always add 360 to your angle right here, and so let's see, 210 plus 360 is going to be 570. Divide both sides by 2, and you're going to get 285. Now that's still within my boundary. I'm going to convert that to radians and get 19 pi over 12. Okay, so we're still good. 19 over 12 is 1 and 7/12. So we're still between 0 and 2. We're good. This next one's not going to work, by the way. We're going to take 570 plus 360, and we're going to get 930. Divide both sides by 2, and you're at 465 degrees, which of course is bigger than 2 pi. But if you want to see it in radians, that's fine. 465 degrees in radians is 31 pi over 12. And of course that would be the same thing as 2 and 7/12 pi, which is too big. So we reject this answer here. Let me get a drink here real quick. And here we go. Okay, students, we're going to solve this trig equation. Now, notice something right off the bat. We have two trig functions, tangent and cosecant. That's usually a sign that we want to make some substitutions. But before you do that, listen to me. Always try to get one side equal to 0. Sometimes you can factor and come up with two equations set equal to 0. And each equation only has one trig function. And that's exactly what's going to happen. Watch. Just watch and see what I'm talking about. Bring this over so you have one side equal to 0. I would always recommend you do that first, just to see if you can factor. And you can. This term here has a tangent squared. This term here has a tangent squared. So if you pull it out, you're left with cosecant x minus 1 equals 0. Look, we have two equations. Two parts. 1, 2. And each part only has one trig function. So we're good. I can take this part, set equal to 0, and solve. I can take this part here, set equal to 0, and solve. So, take the square root of both sides. Tangent x equals, of course, plus minus 0, so it doesn't really matter. 0 is not positive or negative, so 0. Now, if I'm looking for an angle that gives me 0 when I take tangent of that angle, guys, we've got to be very careful here. And remember, it's going to be one of my quadrant angles, so I'm very quickly going to take the tangent of 0, and that gives me 0. Tangent of 90, that does not give me 0. Tangent of 180, that gives me 0. Tangent of 270 does not give me 0. And that's as far as I go, because my domain right here stops right before I get to 360. So the two angles here are 0 and 180. Of course, in pi and radians would be 0 and pi. Now let's solve this equation. Cosecant of x equals 1. Now students, think about it. I want an angle that gives me a 1 right here, okay? But students, listen, I want to know all the answers from 0 all the way to 360 degrees, okay, all of them. And, I know that getting out a 1 here more than likely means my x is going to be 0 or 90 or 180 or 270 or 360, whatever. So listen to me carefully. Think about this, guys. Listen to me. I don't have a button on my calculator that does cosecant, so I'm going to use the reciprocal. And I'm going to flip this side. That gives me sine. I'm going to flip this side over here. When you flip 1, you get 1. Okay? Now let's see what angles I'm coming up with, okay? Let's watch this very carefully here. I'm going to start off with 0 degrees. The sine of 0 is 0, so that's no good. The sine of 90 is 1. So please listen, think about that, students. If the sine of 90 equals what? 1, then the cosecant of 90 equals what? We have to flip this. That's still 1. So there's one answer. 90. Let me say that again. The sine of 90 equals 1, okay? So, if the sine of 90 equals 1, then the cosecant of 90 equals, well, you take this and flip it, and it's still 1. So there's one answer. Now let's try 180. The sine of 180 gives me 0. The sine of 270 gives me negative 1. That's not going to work, guys. Think about it. If the sine of 270 is negative 1, then the cosecant of 270 would be, well, flip negative 1 and you still get negative 1. That's not going to help. So the only answer that works here is 90, okay? Which is pi over 2. So this problem here has 3 answers. These are really tough to do, guys. You just have to be really familiar with the equations and watch your little mistakes. Okay, moving on. Expand and simplify. Okay, now look, what we're practicing here is you using your trig identities. Okay? Using your trig identities. So, as soon as I see, listen to me, students. As soon as I see I have sine here and I have 2 numbers being added here, I think of this trig identity right here. I did not want to do that. I think of that trig identity right here. Do you see it? Sine of u plus v. Well, Mr. Earhart, you're getting old and senile. What about this over here? Well, listen, guys, we can bring that down later. In fact, we're going to bring it down later. Right now, we're just going to work with this right here. Okay, we'll bring this down later. I'm not worried about that right now, okay? Alright, so here we go. With that in mind, I notice I have sine and 2 numbers being added like this, u plus v. So I'm going to call x. I'm going to call x my u. I'm going to call 3 pi over 2 my v. So here we go. Sine of u plus v equals all of this. So in place of this whole expression right here, I'm going to put this. Sine of u, that's sine of x, cosine of v, cosine of 3 pi over 2. Okay? So I'm going right along in order here. Plus cosine of u, u is x, times sine of v, v is 3 pi over 2. So I have all of this times, bring your cosine down. Now, we can do some simplifying here, students. This is 270 degrees, okay? So the cosine of 270 is 0. So I really have this now. See this cosine of 270? That's really 0. So I have sine of x. Sine of x times 0. Plus, now sine of 270, or 3 pi over 2, is going to be negative 1. So this whole thing right here becomes negative 1. So sine times 0 is 0. Plus cosine times negative 1 would be negative cosine x. All of that times cosine x. 0 minus cosine is negative cosine times cosine. Well, a negative times a positive is negative, and cosine times cosine is cosine squared. Look at that. This whole expression here simplified all the way down to this expression here. Okay, moving on. Okay, given that we have this and that we lie in quadrant 2, we're going to find cosine of x over 2. Now please listen carefully, students. We do not know what x is. So how in the world are we going to find cosine of x over 2? Well, once again, they're testing your ability to remember that we do have some trig identities that help us do this, okay? And here's that trig identity. Look at it. Cosine of x over 2. So we're doing pretty good here, okay? Now, we're in what quadrant? 2. Mr. Earhart, why does that really matter, knowing what quadrant we're in? Because, students, you have to know whether to pick a positive or a negative. And remember, whatever quadrant x is in, that's the sign that you use, depending on what trig function you have. So in quadrant number 2, the signs go positive, negative, negative, sine, cosine, tangent, positive, negative, negative. So I'm doing with cosine. I'm in the second quadrant. Cosine's negative, so I'm going to use the negative sign. That's why it's so important to know what quadrant you're in. Okay, moving on. Moving on. So cosine of x over 2 equals negative. So I've got a negative sign. Cosine of x over 2 equals this. This is a 1. 1 plus cosine x. So 1 plus, now hold it. What is cosine x? Negative 3/7. All over 2. This is pretty simple, guys. 1 plus a negative is 1 minus 3 sevenths. That would be 4 sevenths. All over 2. So then I have, well, 4 sevenths divided by 2. So 4 sevenths divided by 2. Or if you flip that, times 1/2, and you get 2 sevenths. Okay, so we're doing really well, guys. This is pretty simple. All I have to do now is simplify my answer, and I'll be home free. Okay, so here's the answer I have. I know my whole radical's negative. I know I have square root of 2 over what? Square root of 7. So multiply the top and the bottom by square root of 7. And if you do that, you'll get negative square root of 14 all over square root of 7 times square root of 7 is 7. Okay, booyah, we are done. There's the answer. So you found, this is so cool, students, you found the cosine of x over 2 without even knowing what x is. You have no idea what the angle is, but you're able to do that because of trig identities. Okay, moving on. A vector v has the initial point and a terminal point. Find its magnitude and direction angle. Now guys, you do not want to try to find magnitude and direction angle unless you first write your vector in component form. Do you remember how to do that? Don't answer that question. I'm going to show you, okay? Remember, it's always terminal point minus your initial point. Okay, so it's really easy to do. I have a terminal point of negative 1, 9 minus my initial point of 2, 5. So, negative 1 minus 2 is a negative 3. 9 minus 5 is 4. So there I just took this vector and I wrote it in component form. I did not want to do that. I have stuff that's erased to save space. Did not want to do that either, so I think I'll just give up. How's that sound? So here is my component form. Got it? There's my component form. Now, find the magnitude and the direction angle. Okay, no problem. Should be a piece of cake. Negative 3, 4. Negative 3, 4. About right there. So there's my vector. I went over 3 and up 4. Over 3, up 4. Then there's my vector right here from here to here. So find the magnitude and the direction. Well, the magnitude's easy. The magnitude's always the distance from the origin to your terminal point here. So using Pythagorean's theorem, we get 5. So there's the magnitude 5. The direction angle is always the angle from here to the hypotenuse. So all I have to do is find this angle here, x, and I can find this angle from here to here. So I'm going to use tangent. I'm going to say tangent of x equals opposite over adjacent, 4 over 3. So second tangent, I'm getting 53.1, so I'm just going to put 53 degrees. So from here to here then, my answer is going to have to be 127 degrees, because 127 degrees right here. There's my 1 right there. 127 degrees plus 53 gives me a total of 180 all the way around. So there we go. My magnitude's 5. My direction angle is 127 degrees. Okay. Now if they wanted that in radians, you just simply convert it over, and it would be it'd be really weird. It'd be 127 pi over 180. Alright, but we're not worried about that. We'll keep it in degrees. Okay, moving on. Now, the given vector v has this magnitude in this direction, and vector w has this magnitude in this direction. Find v plus w. Guys, you do not want to add v plus w unless you convert these both over to component form. So, v has a magnitude of 100 and a direction angle of 172. So let's start with vector v, okay? Direction angle of 172, so all the way to here. That leaves me this small triangle with what degree here? 8. And my magnitude's 100, so my hypotenuse is 100. So I want to find my distance going over. We'll call that x. Don't forget it's negative because you're going across this way and you're going up. So it'll be a positive. You're going to find your y. How do I find my x? Adjacent hypotenuse. Cosine of 8 degrees equals adjacent over hypotenuse. Multiply both sides by 100. And I get 99.03. I'm just going to put 99. So 99 equals x. So it's going to be a negative 99. Don't forget that. Okay, now let's find y. Opposite over hypotenuse. So sine of 8 degrees equals opposite over hypotenuse. Multiply both sides by 100. And we'll get 100 times the sine of 8 degrees as 13.9. So I'm going to put 14. So this will be 14. So vector v is, in component form, it's over, so negative 99, comma, and it's up 14. So there's vector v in component form. And that was really done pretty simply, students, not difficult at all. Now let's find vector w in component form. So the direction is 310. So I rotate 310. That leaves me 50 degrees here in my triangle. That's easy. And my magnitude is 300, so my hypotenuse is 300. This will be a positive x. I'm going this way. A negative y going down. So here we go. We'll start off finding x first, adjacent over hypotenuse. Cosine of 50 equals adjacent over hypotenuse. Multiply both sides by 300. And we're going to get 193, rounded of course. So this will be 193. Now let's find y, opposite over hypotenuse. So the sine of 50 degrees equals adjacent or opposite over hypotenuse. Multiply both sides by 300. 300 cosine of 50 is going to be, 300 sine of 50 is going to be 229.8. I'm going to put 230. So this is 230 negative. So there's w. W is 193. And then down 230. And now, students, the rest of it's a piece of cake. We're simply just going to do what to these two vectors? Add them. So I have negative 99 plus 193. And that's going to give you 94. Then I have 14 minus 230, which is going to give me a negative 216. So there's my two vectors being added together. Moving on, for the triangle A, B, and C, find side A. Now you know Mr. Earhart. I just draw a regular triangle up here. I'm not going to get fancy. A, B, C. I fill everything in. 39 degrees, 106 degrees, and C is 78. We're going to find side A right here, okay? Now I want to tell you, students, I wish right off the bat that I had a pair, so I could use law of sines. Like I wish I knew a side and an angle, or a side and an angle, or a side and an angle, but I don't. So I'm going to have to use law of cosines. Now the only thing I can solve for using law of cosines is angle C. There's nothing else I can do, guys, okay? So I've got to find that first, and then once I find this, I'll have a pair. And then once I have a pair, I can go ahead and use law of sines to find side A, okay? So we're going to have to use law of cosines first. Hopefully you remember how to do this. It's going to be 78 squared equals 30, no, maybe not, hold on one second. I'm drawing a blank here. Let's see. We're looking for this angle here. Oh, I'm sorry, guys. Your old math teacher's getting old and senile. What am I thinking, guys? Wow, that's really embarrassing. We can find this third angle so easy by adding them, by adding these two together and subtracting from 180. I was testing you guys to see if you would catch my mistake. That's a lie. Alright, 39 plus 106 is going to give you 145. So these two angles added together here are 145. So this angle here has to be 35, because now all three of these angles right here will add up to 180. So now I So I can say 78 over the sine of 35 equals, now I'm solving for a, so the angle that goes with a is 39, equals a over sine of 39. Okay, let's cross multiply and then divide. So here we go. I would have, if I cross multiply, 78 sine of 39 equals a sine of 35. Okay, now divide both sides by sine of 35, and you would have this up here, 78 sine of 39 divided by sine of 35 equals a. Now students, if you don't get the answer that I say you should get, please check your ability in typing this into your calculator. It is very easy to make a mistake, okay? So I'm going to type in 78 sine of 39, enter, and then you'll get 49.0869905, then divided by sine of 35, enter, okay? And you're going to get 85.58. I'm going to put 85.6. So we did it. Moving on, we just found the length of A. Alright? Okay, now let's go ahead and draw a picture and see what we got here. And maybe I can do this problem here without messing it up. Let's see. Probably not, but I'll try. Alright, A, B, C. So side A is 78, side B is 15, side C is 91. And they want us to find all the angles, okay? Well, we're going to start off first of all by using law of cosines, okay? Law of cosines. Hopefully you remember what I taught you. I told you guys to always, always, always solve for the largest angle first when you're using law of sines, law of cosines. So please, please find your largest angle first, okay? Well, the largest angle is always going to be across from the longest side. My longest side is 91, so my largest angle is C. So I'm going to solve for C first, okay? So here we go. 91 squared equals 78 squared plus 15 squared minus 2 times 78 times 15 cosine of angle C. Okay? Now let me grab my calculator real quick here. This will be a little messy, but here we go. 91 squared is going to be 8,281 equals 78 squared is going to be 6,084. I'm going to put that right here. I'm going to save some space. Plus 15 squared, of course, is going to be 225. So I'm going to add those two together real quick. And I'm going to get 6,309. And then negative times a positive would be negative. 2 times 78 times 15 is going to be 2,340. Now a lot of students here, when they're solving for this angle, like to move both of these numbers over. Please don't do that. This is one term right here. They have to stick together. They're multiplying. However, I can move this over and make it negative, okay? So that's what I'm going to do. So 8,281 minus 6,309 is going to give me 1,972 equals negative 234. And actually, guys, I'm very sorry. Please accept my apology. This is 2,340. So please squeeze a 0 in here right here. Okay? I'm going to check that one more time and make sure I'm right. Yes, so it should be a 0, so negative 2,340 cosine of C. Now divide both sides by negative 2,340, so 1972 divided by negative 2340. I'm going to round negative 0.842735 equals cosine of C. Well, you guys know what to do. You're looking for an angle, so you're going to hit second cosine. And then type this number in right here. Negative 0.842735 5, and we should get out the right answer. So here we go. 147.4. I'm just going to put 147. So 147 degrees for angle C. And I hope I've not made any mistakes there. Okay, now let's continue on. I have a pair, guys. That's real exciting. Now I can say 91 over the sine of 147 equals, we'll do angle A next, 78 over sine of A. So trust me, guys, if you cross multiply and divide, you'll get this. Sine of A equals 78 sine of 147 divided by 91. So we have sine of A equals 78 sine 147, enter, divided by 91, enter. I'm getting 0.4668. So the second sine of that gives you 27.8. I'm going to put 28 degrees. And if you're close on those, on a test or a quiz, that's totally fine with me. So we can find this third angle very quickly by taking 28 plus 147, enter, subtract that from 180, and you will get 5 degrees. There we go. So we found all three angles. Okay, moving on. Now, given this, find v times w, dot product. The dot product of vectors. Well, vector v is really 5 comma negative 2. Vector w is really negative 3 comma 1. How do you find the dot product? We multiply first number times first number. Multiply second number times second number. And you add them together. Very simple. I don't know how to make that any easier. Okay? Alright, moving on. Okay, we're going to find the angle between these two vectors here. Okay? The angle between these two vectors here. Now, there is a formula. Okay, here it is. There's the formula. So all that we have to do here is take the dot product of these two vectors and their magnitude. Find the magnitude. We'll be fine. So I'm going to do that real quick. W is 5 comma 2. V is negative 10 comma negative 2. Okay? Now, let's find the magnitude. This is W. This is V. Let's find the magnitude of W very quickly. Remember how to do that? You simply add both numbers. You square both numbers, add them, and take the square root of it. Okay, if you don't remember that, make note of that. You add the two numbers, square both numbers, add them, take the square root of it. If you don't like that, you can draw it if you want. Over 5, W is over 5 up 2. So over 5 up 2, and then use Pythagorean's theorem, which is the exact same thing as this right here. I'm just trying to save you some time, okay? Alright, so you would get square root of 29. 25 plus 4. Now very quickly, same thing with V here. 10 squared plus negative 2 squared, negative 10 squared 2. Either way you get out, doesn't matter. You get out a positive number. So when you square negative 10, you get a 100. When you square negative 2, you get a 4. So the square root of 104. Now what's the dot product? Well, that would be negative 50 and negative 4. Take the first number times the first number, negative 50. Take the second number times the second number, negative 4. Add those together, you get negative 54. So we have everything we need right here to substitute into our equation. So here we go. Cosine of theta equals, this is the formula, guys. This is the formula that gives you the angle between vectors, okay? Alright, so W times V is your numerator, and that's negative 54. Magnitude of W is square root of 29 times the magnitude of V is 1 and square root of 104. So it all comes down to calculator work now, okay? I'm going to very quickly take the square root of 29, enter, and I'll get 5.3851 times the square root of 104. Enter, and I'm going to get my entire denominator here is 54.9181. So second cosine of that number will give me 169.5 degrees. I'm going to go ahead and say 170. But if you round it somewhere else, that's fine. There you go, guys. I mean, just use the formula and you'll be fine, okay? Alright, moving on. Rewrite the complex number in trig form. Well, this should be done so very quickly, students. It's not difficult at all. -2, positive square root of 3. I don't care if my triangle is drawn to scale. Not a big deal. So I went over how far? 2. I went up how far? Square root of 3. So now find the hypotenuse very quickly. You should get square root of 7. Now I did that in my head, which is very scary. Let me check it. Square this, you get 3. Square this, you get 4. 7, yeah, square root of 7. So we're doing really well. We found the magnitude already. Now all we have to do is find this angle here, and then we'll know what the direction angle is, which, let's pause. Maybe I went too fast here. Whenever you're writing a complex number in trig form, you need two things. You need the magnitude or the distance of the hypotenuse, and you need a direction angle, okay? Alright, so how can I find x here? Well, I'm going to say tangent of x equals adjacent over, or excuse me, equals opposite over adjacent. So there we go. So second tangent, square root of 3 divided by 2. 48 or 40.89, so 41 degrees. So this angle inside the triangle is 41 degrees. So that angle right here then must be 139 degrees. So here's what you do to remember. Trig form looks like this. Your hypotenuse goes here, or your magnitude. Then you put parentheses, and you put cosine of your direction angle plus I sine of 139 degrees. There we go. That's it. That's trig form, okay? Not too bad. Okay, moving on. Now, lastly, and we're finally done, let's find the 3 cubed roots of a complex number. Now, students, you never want to try to find the 3 cubed roots of a complex number if you don't have it written in trig form. You want to write it in trig form. You just have to. Makes it so much easier. So -64 plus 0i. Let's write this in trig form. It's going to be really easy. So easy. Okay, we go -64 and then 0. So there's your line right here. That's it. There it is. So what's the distance? 64. What's the direction angle? 180. It's that easy. So 64 cosine of 180 plus I sine of what? 180. Now, students, please listen to me. Please listen to me. I wrote my number from standard form to trig form. Got it? Or they call it rectangular form too. Either way, to trig form. Now, I want to find the 3 cubed roots. So that means I'm going to have how many answers? 3 answers. Okay? So I'm going to have 1 answer here, 1 answer here, and 1 answer here. 3 answers, okay? Now, here's how you find your answers. We're dealing with cubed root, so whatever the number is on the outside here, you always take the cubed root of it, okay? Well, the cubed root of 64 is 4. Then, whatever root you're dealing with, in this case we're dealing with cubed root. Cubed root. So we're going to divide these numbers by 3. If it had been a square root, we would divide these angles by 2. If it was a 4th root, we would divide our angles by 4. It's a cubed root. So we're going to take our numbers here and divide by 3. So there's 1 answer. Well, Mr. Error, that's 1 answer. It's not going to fit, is it? Mr. Error, there's 1 answer. How do I find the other 2 answers? Well, I'm glad you asked. It's so easy. You always take 360. That will never change, never. And you simply add 120 degrees over and over. So 60 plus 120 is 180. And then add 120 again. It's that simple. There we go. So there's your three answers. Okay. So students, there we go. Not too difficult. Hopefully this review's been a help to you. Don't hesitate to call or email if you have any questions.